Good morning, everyone. We're going to continue on with our quadratics in quarantine. Just as a recap, we have learned that quadratics can come in the form of standard form. But the last couple days, I cannot remember anymore, we've been dealing with quadratics in vertex form. And we learned that all these letters here move our basic quadratic parabola up, down, stretches them, compresses them, left to right. So our most basic quadratic parabola is y equals x squared, and that's part of this vertex formula. Here's the y equals x squared. And we learned that what this a here does is it stretches or compresses the parabola. So it would take our y equals x squared parabola, and if this number is greater than 1, it would stretch it up higher. If this number is less than 1, it would compress that same parabola. We learned that the h moves it left or right. And we learned last day that it was the opposite of what you see here. So if you see negative h, you are moving right. And if it's a positive h, you are moving left. And the reason for that is we are dealing here just with the h. So if h is 5, x minus 5, so just subbing in 5 for the h, h being positive 5 looks like a minus 5. And if h was negative 5, when we sub that in, it appears as a positive. So a negative 5 appears as a positive 5, and a positive 5 appears as a negative 5. And that's why we're moving in the opposite way that we would think we're moving. And here k, this is our up or our down. Now, it's possible to have no stretch or compress, no left or right, and no up or down, hence our most basic formula, and we can have all three of those. In fact, we can have a fourth operation, and that is transformation. If this is a negative a, that tells us that it now flips downwards or opens down. So we can have up to 4 different transformations. And when we're doing them, we apply them in a certain order. So the first one that we would do would be the vertical stretch or compression. So we deal with the a first. Secondly, if there's any reflection, and that's if we have a negative a, we would do that second. Third, we would deal with our left or right, which is our h. And fourth, we deal with our up and our down, which is our k value. Now, a little bit of information here for you. If a and k have opposite signs, we get 2 zeros. Now, what is a zero? A zero is any place a parabola crosses the x-axis. So our most basic y equals x squared parabola has 1, 0. It meets the y-axis at, or sorry, the x-axis at one spot. This parabola here has 2 zeros, and this parabola here, shifted up and to the right, has 0 zeros. Just looking at our equation in vertex form, we can tell whether it has 1, 2, or no zeros. So if the a and the k value have opposite signs, we're going to have 2 zeros. And if a and k have the same signs, we will have no zeros. We can also tell where our vertex is going to be. So as a reminder, this point, this point, this point, these are the vertexes. We can tell looking just at our formula in vertex form where the vertex is going to be. So the vertex is located at h, k. So if our formula here is y equals a x minus 4 squared plus 3, that tells us our h here is a positive 4, the opposite of the sign, and our k value is 3. So we can find our vertex. We can also find our axis of symmetry without actually having to graph it as well. So our axis of symmetry is that line that passes through the vertex where both sides of the parabola are symmetrical to each other. And in this case, our axis of symmetry is equal to h. So we would say here that in this case, our axis of symmetry is, it passes through 0 on the x-axis. If this here is passing through, let's say this is 3, then that one would be x is equal to 3 for the axis of symmetry. So in this case here, this particular parabola here, our axis of symmetry would be 4. All right, so let's do a little bit of work with these. All right, so we can see in this case that we have no A. I'm just gonna write it in a different color here. We have no A, so we are not gonna be stretching or compressing, and there's no negative sign out front here, so we are not going to be flipping downwards. So we are going to be moving left or right. We are going to be moving up or down, and that is it. So first of all, if we were to graph this, and once again, I apologize, I do not have any graph paper. First of all, the way we do this is we start by graphing our first initial parabola, our y equals x squared. So that's at 0, 0. 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4. So here is our initial y equals x squared. And I'm going to change colors here. So the first thing that we're going to do is we're going to deal with A. We don't have any stretch or compression, so we don't have to do that. The second thing is we don't have a negative, so we don't have to reflect it downwards. The third thing that we deal with is the h. And in this case, our h value is negative 2. We know it's negative 2 because that has simplified to a positive 2. So we are going to move this 2 spaces left. So 0, 0 goes 2 spaces left. 1, 1 goes 2 spaces left. 2, 4 goes 2 spaces left. So everything shifts over 2 spaces. And we get so there is our first transformation. Our second transformation is we're going to look at our up or down, and we can see here that this goes down 4. So now we're going to move this whole parabola down 4. So this point moves down 4. This point moves down 4. This point moves down 4. All points move down 4. And we get our second transformation. Now in reality, I'm not moving every point down 4. Once I've moved my vertex down, then being good at drawing the original, I just draw this the same way. Over 1, up 1, over 2, up 4, over 3, up 9, so on and so forth. So there is our graphed transformations. Where's our vertex? Our vertex, of course, is at HK. So in this case, it's at -2, -4. So we have -2 here, -4. So our vertex is at -2, -4. Our axis of symmetry, that's our H value. So it is at -2. That tells us that our axis of symmetry runs through -2. And I should put x is equal to -2. Do we have a stretch or compression factor? The answer is no. So we stretch it or compress it by 0. Which way do we open? We open up. Values x can take, just real numbers. And values y can take. Now x can literally take everything. If we drew this 3, 9, 4, 16, 5, 25, and we kept going, literally this parabola would encompass all x values. For y values though, it doesn't encompass all y values. In this case, y is equal to or greater than -4. So we can see our first y value on the y-axis at -4, and it'll also pass -3, -2, -1, 0, but it will not encompass -5 or lower. So our y value here is equal to or greater than -4. Example number 2. We have an equation in vertex form of so in this case, if I put some brackets here, you can see that we have a stretch or compression value. We have a reflection, so this is going to open downwards. We're going to be moving up 3. What we don't have is an H value, so we're not going to be going left or right. So if I rewrote this out, it'd be -2 x minus 0 squared plus 3. So because our H value is 0, we can leave it off, but we do know that it's really there. So first of all, graphing this, we will start with our initial y equals x squared, so 0, 0, 1, 1, 2, 4, 1, negative 1, 1, negative 2, 4, and we have our initial parabola. So we are to do the a first. In this case, we are going to stretch it by 2. So what that means is, instead of going over 1 up 1, we're going to go over 1 up 2. We're going to double that y value. Instead of going over 2 up 4, we're going to go over 2 up 8. Over 1 up 2, over 2 up 8. So our first transformation, we can see that it stretches upwards by a value of 2. The second transformation that we do is we look at the negative. So in this case, we are going to flip this downwards. So we're going to go over 1, down 2, over 2, not down 4, but down 8. Sometimes I have students actually do this, turn it upside down and redraw that. So over 1, up 2, over 2, up 8. And you know what, I'm going to draw this in a different color here so we can see that. So you can see this pink parabola has been reflected downwards. So if you need to rotate your paper to draw it, feel free to do that. Our third transformation here is left or right. We don't have a left or right transformation. And our fourth one is to move this up 3. So we're going to move all these points up 3. The vertex is going to move up 3. This point is going to move up 3. This point is going to move up 3. Once again, if you want to rotate your paper and just draw that parabola in again. So over 1, up 2, over 2, up 8. Or if you prefer just to draw it upside down, that's fine as well. You can see our third transformation though, that this parabola has just shifted up 3 spaces every point. So there we go, our completed drawing. I do suggest that you, of course, label your transformations. Using different colors really helps as well. So our vertex, here's our vertex right here. It's our h and k value. So we know that it's at 0, 3. Our axis of symmetry is our h value. So it's 0, and we can see here it is running right through the vertex. Our stretch or compression value, we know that we stretched by a factor of 2. Our opening is down. Our values of x, once again, are real numbers. And our values of y. So in this case, y is equal to 3, or it is less than 3. So our greatest y value will be 3, and it'll include all y values less than that. It doesn't get much harder than this, ladies and gentlemen. So let's do, I believe we have another example. And then we can call it a day. So y equals 1/2 x minus 3 squared minus 1. So we can see here that we have a compression value of 1/2, no negative, which means it's going to open upwards. We have an h value, so we are going to move right 3. And we have a k value of -1, so we're going to shift down 1. So drawing our initial y equals x squared, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So there's our initial. First thing we do is we deal with the A. We're compressing it by a half. So what that means is, instead of going over 1 and up 1, we're going to go over 1, up a half. Half of a 1. Over 2, up 4 becomes over 2, up 2. Over 3, up 9 would be over 3, up 4.5. And on the other side of the axis of symmetry, same thing. Left 1, up a half. Left 2, up half of 4. Left 3, up half of 9 to 4.5. And we have just compressed that parabola. When you compress a parabola, it becomes wider. If you're stretching it, it becomes narrower. The second thing we do is we deal with the negative. If we have one, we don't. The third thing that we do is we deal with the H. This tells us that we are going to go right 3, so this whole thing shifts over 3. And from there, over 1, up a half, over 2, up 2, over 3, up 4.5. Likewise, the same in the other direction. Left 1, up a half, left 2, up 2, left 3, up 4.5. And we have our second transformation. The last thing we deal with is the shift this down by 1. So the vertex moves down 1, over 1, up a half, over 2, up 2, over 3, up 4.5. And you'll see that my preferred method of doing this isn't just to try to move every single point, but move that vertex and then just work off of it, drawing my parabola. So I'm not trying to move that point down. I'm just going to replot that point over 1, up a half, over 2, up 2, over 3, up 4.5. Oops. And we have our third transformation. So our vertex is located at HK. So we are at 3, negative 1. Once again, remembering our H value here is 3, and that's what makes this whole thing a negative 3. If it was a negative 3, this would be x plus 3. So there's our vertex. Our axis of symmetry is our H value. So we know that our axis of symmetry here goes through 3 on the x-axis. Our stretch or compression factor is 1/2. Our direction of opening, we open up. X takes on the value of real numbers. And in this case, Y is greater than or equal to negative 1. So that's it, ladies and gentlemen. If you do have a printer, you're fortunate enough to have a printer and you haven't run out of ink yet, I would probably pop on to the internet and try to print up some graph paper. Particularly if you can find a piece of graph paper that looks like this. It's a great tool for doing multiple one of these and not having 1,000 sheets of paper. I'll take a picture of this and send it to you in case that's something that you can print up as well. Other than that, practice these transformations, number them as you go along. Remember to start with your base one first and work off of it. Follow the correct order, and using colors is definitely something that will help you out. All right, have a great day, everyone.